All right, lesson 4, page 2, explore and practice together. We are now going to multiply and divide radicals. Remember, we were combining like terms when we were adding and subtracting. Now when we multiply and divide with radicals, we want to pay attention to the same indexes. Remember that product rule. As long as the indexes are the same, we can multiply what is underneath the radical sign. Okay, sometimes when you do that, things need to be simplified and something can be taken out from underneath the radicals. So as long as their indexes are the same, we do not need identical radicands when we multiply, only when we add and subtract. Okay. Once your indexes are the same, you are allowed to multiply the numerical coefficients in front of them and then multiply all the terms that are underneath the radical sign together to get a final result. When you multiply them together and this needs simplifying some more and something needs to be taken outside the radical, make sure you do that. Same goes for the higher powers. As long as the indexes are the same, you're allowed to multiply the numerical coefficients. If there isn't one, there's a 1 there, right, that you don't see. So that's just 1 times -5 in this case, and then everything that's underneath here. And then don't forget, when you're multiplying, if you're multiplying, which you're doing with these, you're going to be adding their exponents, which is why we reviewed that for a minute. That gets you here, okay? The 2 can't be simplified, but the 7 can. This is an index of 5, so 5, 2x, 7. That's 7 divided by 5 is 1 and 2 left over. That means we need to take 1 out, okay? Put it here, and then the 2 stay underneath because we had 7, okay? So it's combining things we have learned. So when you're distributing them, the same thing happens. It's outside times outside, inside times inside. Where to go? Over here. Outside times outside, inside times inside. All right. And then outside times outside, inside times inside. This is exaggerated every single step, okay, to show you how this works. So this is 21, this is 60, this is -35, this is 90, okay? Now, once I've done that, these are awfully big radicands here, okay? So we need to check and see if they can be simplified. So there is 60 has a perfect square root for a factor of 4, so that needs to come out, okay? 90 has a 9 in it, so that has to come out. So we're going to take this out as a 2 and multiply it by the 21. We're going to take the 9 out and multiply it by the 35. So remember, we're taking out the square root of 9, which is a 3. So 3 times that, and this is what's left over there. And that should be a negative, shouldn't it? Yeah, that's a typo right there. Because this negative right here, right? And that didn't change, so I'll fix that. And then you're left with 2 terms that you cannot combine because they're not like terms, okay? Excuse me. Let me write that down before I forget. Okay. Let's check this one out. All right. This one we're going to FOIL. Okay. Get all this out of the way here. All right. So the 1 that's here times the 4, and then the 5 times the 10. That gets me that term, okay? Outside times outside, inside times inside. That's the first times first. So this is all the first for the FOIL, okay? And then outside, this times this, I should probably use different color. Here, let me try that again. All right, so this is this here. That's that one. This here is this one. 6 times 1 is 6. 6 times 5 is 30. Then this one here, -8 and 30. And then this one here is this one here. Okay? So any of these, notice that some of these need to be themselves simplified. Okay? So let's look at the first one here. 450. That is the square root of 25 and the square root of 2, right? So the 25 comes out as a 5, which needs to be multiplied by the 4, and the 2 is left. That is going to get you 20 square root of 2. Okay? This one here, 30, is not reducible. What's in a 30? 5, a 2, and a 3. So there's no squares in there, so the square root of 30 has to stay. So that stays as is. This one stays as is. Same thing. And 18 has a 9 in it, which is a 3. So 3 comes out and gets multiplied by the 12. That is going to give you a -36 square root of 2. Okay? So then we are combining these two here because they're like terms. So 6 minus 8 is a -230. That's here. And then 20 minus 36 is a -16, which is here. And then these are not like radicans, so you can't combine them further. So that's your final answer for that. Okay, so yeah, there's a lot going on these, and you got to keep things straight. So let's try that. So we have cubed root of 10. Cubed root of 2, they can't be simplified, but since I'm multiplying, I'm allowed to put them together. So 7 times 4, and the cubed root of 10 times 2 is going to give you 28 cubed root of 20. And there's nothing I can do with that. So that stays, okay? Think about what's in a 20. A 2, and a 5. So there's no 3 anything terms to come out, okay? 3 of anything. So let's see. Square root of 30. Let's see. What's in a 30? A 3, a 2, and a 5. Can't be reduced. So if we're multiplying, though, they're both the same indexes. So this is 30 times 3, which is 90. 90 has a 9 and a 10. So the 9 is a perfect square of 3, square root of 10. Okay, these get really kind of tricky. So if you're trying to memorize anything, it's not going to work. Just know the rules so you can apply them as you go. Okay, each problem is going to look different. All right, 5th root of 32. Is it 2? I could take that out first. The X and the Y don't come out because there's not enough. But I could take out a 2. This right here is a 2 times that is 6. X, 5th root of x, 4. Y squared. 5th root of 243. That's on the list of 5th roots, right? 243 is a 3 5 times. So this right here is a 3. So that can come out. And so can a y, actually. Let me fix that. So let's say you didn't notice that. Is it okay that I multiply 32 times 243? Yes, it's just, you're going to get this big whopper number. I think it comes out to 7,776. So if you didn't notice, then you're going to have to take the 5th root out of 776. So that's just, it works, but it just takes longer that way. 3y comes out, x, y. Right? All right. Okay. So, write the index in here. Because if the indexes are the same, you're allowed to multiply. So 6 times 3 is 18. Let's go there for a second. Then we want to put all the y's together and all the x's together. There's going to be 5 of them now, right? 1 and 4 more is 5. 2 and 1 more is 3. So I need to take another x out. So 18x, and then the y's stay in there. Oops, forgot that y right there. Rats. Okay, so 18xy, 5y3 is the correct answer for that one. Okay. Not a lot of room to do these. Excuse me. All right, let's try this one. Distribute. 10. What is 7 times 14? Put it in the calculator real quick, just to double check. Yeah, 98. And then this one, 5 times 1 is 5. 35 times 7 is 245. Goodness, so you know that they're going to reduce. They're not perfect squares. 98. Let's see, 49 square times 2. So that's 72. And the only reason I know 49 off the top of my head, think about it. 49 plus 49 gives you an 8 on the end, okay? You're just going to have, the more you do, the more you get used to doing that. 245, that's a tricky one. You could try 25, that's not going to work. What else? Another big one of your squares. 49. 245 divided by 49 is 5. Yep. Okay, so 7, 5, negative 35 square root of 5. Those are not like terms. Once you switch from multiplying to adding, you need the radicand to be the same. So even though the index is the same, the radicand's not the same, so that's your final answer for that. All right, let's FOIL this one. 25 minus 5 is on the outside times 1 is negative 5, and then that, okay? So these are a little tricky. There's no inside and outside, sort of. Just keep everything straight. All right, watch this one. This is going to be the same index, so I can multiply 5 times 5, so that's the square root of 25. So 25, and then look, combine like terms, these go away. And what is this here? What is the square root of 25? Is minus 5, so that's 20. Okay, these are tricky. All right, and you can hardly see it, but right in here is my next problem. Let me do it in green here so we can see. So 2, square root of 2 plus square root of 7 times each other. Please take the time to rewrite this out. It is not going to be the square of the first one and the square of the second one. It is a FOIL problem. So make sure you write it that way. All right, so the square root of 2 times the square root of 2 is the square root of 4, right? 2 times 2 is 4. One step at a time. Plus square root of 14 plus square root of 14 plus square root of 49. Square root of that is 2. 2 plus that is 2 of those. And that's plus 7. So your final answer on this last problem is, what, 9 plus 2 square root of 14.